Hi everyone, welcome back to a very fresh session of DNA learning. I'll be handling chemistry for you. Yeah, first of all, let me introduce myself. This is Shivani here, and I'll be handling plus one and plus two chemistry for all the students across India and all those who are following CBSE syllabus abroad too. So, we have uploaded few sessions before, but all those sessions were in Malayalam, and I'll be handling chemistry for the students of plus one and plus two. So after that, we thought like, why can't we take sessions for all the students outside Kerala, uh, and Malayalam, the language which we use, is actually a barrier for other students who are not much familiar with Malayalam. So we thought to take sessions in English also, so that you guys could also have an access to our sessions in every subject, not only chemistry, but also physics, biology, maths, yeah, all other subjects. So let me ask you, how was your plus one? Hope you all had a very good time in plus one, and finally you are in plus two. You have one more year left in school, right? As a school kid or a school student, you have one more year to be there in school, or to enjoy school, to have a lot of memories. So some maybe having a thought to leave school as soon as possible, so that they can get into some other colleges or some other universities abroad, or somewhere around India, or somewhere far from their hometown. So they just wanted to have some vibes, some entertainment, yeah. Or in some other cases, some students will be like, okay, school days are getting to an end. I'm surely gonna miss school, my friends, my memories, my uniform, my teachers. Oh, yeah, there are two types of students, right? But I was a student like, oh, in plus one and plus two, yeah, I was okay with leaving school, because I was so sure that at some point of my life I have to leave school. Okay, I am a person who live in such a thought. Like, I always have such a thought, like, somewhere, sometime, we should, okay, we should leave something which we like the most. So I always have that thought in mind. So I don't miss things that much. Even the college life or the school life, I don't miss all these things much. You can say I'm not so sentimental, maybe, I don't know. But you cannot say that I don't have feelings. I do have feelings like anybody else. But I'm in a thought like, okay, whatever I'm doing now, at some point of my life in future, I have to leave it. So I don't know why I'm saying all these stuffs. Anyways, to all the plus two students who's watching my session right now, at some point of your life or after a few months, you should leave school. It's a universal fact. Yeah, it's how life goes. So you should cope up with the conditions or things that you have to face in future. So just keep that in mind and enjoy every little moment of your life now. Your friendship, uh, maybe your relationship with friends, teachers, or anyone else in school. Yeah. So shall we start with our first chapter, solutions? Solutions of plus two chemistry. Let me tell you that CBSE has removed many of the chapters from the plus two syllabus. When I was in plus one, plus two, I had to study a lot of chapters, literally a lot of chapters than the chapters you are studying now. I don't remember the exact count of the chapters, but before the solution, I had a chapter named, I had solid state, which you don't have now. And there are many other chapters which CBSE has removed right now. So you're really lucky. Shall we start? Okay, solutions. What is solutions? Let me know that. Do you guys are familiar with the term solution? Obviously, yes. What is a solution? What is a solution? There is a solution for every issue, right? That is not a solution when it comes to chemistry. Solution means, yeah, come on. Yes, exactly. Solution means what? It's a mixture. Obviously, it's a mixture of two or more components. So, in plus one chemistry, you might have dealt with the terms homogeneous, heterogeneous mixtures, pure substances, elements, all those terms, right? So, I hope you all studied those things very clearly reached +2. So solutions means it's actually a mixture. It's actually a mixture of two or more components. And how are they mixed? That's the important point. You should highlight that point. A solution is made by mixing two or more components homogeneously. What is homo? Homo means same. So if you mix two or more components homogeneously in a homogeneous manner, they have same properties. Or they share uniform properties, and they are called a solution. We have examples: sugar solution, salt solution. See the screen. Okay? Sugar solution, salt solution. So any solution, if they have two or more components and they are mixed in a homogeneous manner, if they share uniform properties among themselves, they are called a solution. Sugar solution, salt solution. There are many types of solutions. So let me ask you one thing. Are all solutions liquid? Are all solutions liquid? Many are saying yes, many are saying no, many are saying like may or may not be. The answer is not all solutions are liquid. There are gaseous solutions, there are solid solutions, and there are also liquid solutions. So you need to know that solutions are not only liquids, but also they can be solids or gaseous. They can be gases. Before coming to why are they classified between solid, liquid, gaseous solutions, we need to know how a solution is made and what are the components of a solution. I said solution is something that is made up of two or more components and they are mixed homogeneously. Example is sugar solution or salt solution, etc., etc., etc. And you might have heard of the term solvent, solute. What is a solute? What is a solvent? Yes, you know that, right? You're studying in +1. Yeah, okay, class 11. Solvent means when taking the case of solution, the component which is present in larger quantity is called solvent. Okay, consider case of A and B. A and B mixed together makes a solution. A is present in a larger quantity when compared to B, then A is a solvent. Simple. B is not much larger than A. Okay, it's actually the quantity of A is much less than. The quantity of B is much less than A. Then B is a solute. Clear? Whenever considering the case of a solution, the component which is present in larger quantity is called a solvent. The component present in smaller quantity is called a solute. Take the example of a sugar solution. How are you going to prepare a sugar solution? Prepare a sugar solution for me. Or a salt solution. How are you going to prepare it? You are going to take some water in a glass. Then few spoons of salt or sugar. You'll mix it. You stir it well, right? It's now a homogeneous mixture because it's called a solution. Why is it called a solution? When you taking a spoon, you taste some drops of salt solution from the topper surface. Consider this is a glass, okay, full of salt solution. When you take something from the above, some drops of salt solution from above, or some drops of salt solution from the bottom surface, it tastes the same, right? It tastes the same. The quantity of salt present in every minute space of the salt solution is same. It's homogeneously distributed. Clear? So in salt solution, which is a solvent and which is a solute? Solute is something present in smaller quantity. Solvent is something present in larger quantity. So in a salt solution, it is made up of salt and water. Water is in larger quantity, or salt is in larger quantity? Yes, water is in larger quantity. So definitely water is a solvent and salt is a solute. Clear? What is a binary solution? You might know. Yeah, binary. The word itself says binary too. It is made up of two components. A solution made up of two components is called a binary solution. And what is aqueous and non-aqueous solution? Simple. What is a aqueous solution? What is non-aqueous solution? When you are preparing a solution with water as solvent, then it's an aqueous solution. Okay? Whenever there is a solution with water as solvent, it is an aqueous solution. And whenever there is a solution without being used water as a solvent, okay, I use something else than water, okay, to constitute the part of solvent. I use something else as solvent, not water, then it's non-aqueous solution. Non-aqueous solution. Aqueous solution means solvent is water. Non-aqueous solution means solvent is something else than water. Okay? I've already mentioned that solutions are not only in the form of liquids. But in your day-to-day experiences, you might have come across these solutions which are mostly in liquid state. But there are solutions in solid state and gaseous state. So on the basis of what we classify solutions into liquid, gaseous, solids. I've already said that the solution is made up of solute and solvent. So the solution which I prepared has a solvent in solid state. Then obviously the solution that the solvent is going to make, okay, the solvent is going to be a part of is a solid solution. Suppose I'm going to make a solution with solvent in gaseous phase. Obviously, the solution will be in gaseous phase. So the thing is that I've already said you might have come across many examples of solutions, but all those will be in the liquid state because those solutions have the solvent in liquid state. So the thing is that, so what you have to keep in mind is that whenever the solvent is in solid state, the solution will be in solid state. Whenever the solvent is in liquid state, the solution will be in liquid state. Whenever the solvent is in gaseous state, the solvent will be in gaseous state. So it's the solvent which determines the state of the solution. If I'm the solvent, I'll decide what type of solution to be formed, in what state it should be present. Clear? Okay, so tell me, what's the state of solvent in gaseous solution? Fast, quick. What's the state of solvent in gaseous solution? Yes, gas. What's the state of solvent in solid solution? Solid. What's the state of solvent in liquid solution? Liquid. Yes. Brilliant. Now we are going to familiarize with a table given in NCERT. Actually, in majority of the exams, like if you go for the further higher studies, you might write or appear for entrance examinations like CUET, or there are many other examinations, like, right? So in all those examinations, even for your board exams, at least one question or a one-word question from this table is very common. Clear? So this table should always be there in your mind. You should always reserve a position for this table in your brain. Okay, set? I'll tell you how the questions come from this table. So we can see that in gaseous solution, the solvent will always be in gaseous state, but the solute can be in the state of gas, liquid, and solid. For all those different categories, we have different examples, and what's the task given for you or assigned for you is that you should study at least one example for a state of solute dissolved in a state of solvent. They'll ask questions like give an example for gas in gas solution. Give an example for liquid in gas solution. Give an example for gas and solid solution. Give an example for liquid and solid solution. They'll ask the questions like this. So I'm not forcing you to study the examples given here. You're free to study the examples of your choice, but it should be accurate. It should be right. Clear? So let's see what are the examples of different categories given. Gas in gas. Here the solute is gas, the solvent is gas. Gas mixed in gas. Mixture of oxygen and nitrogen gases. Liquid in gas. A liquid is dissolved in gas. Chloroform mixed in nitrogen gas. And finally, the solid in gas. Solid in gas. Solid in gas. What is the example? Camphor in nitrogen gas. Camphor in nitrogen gas. Okay, you're free to search other examples in Google or wherever the sources you have. So all the sources you have. But make sure that the example that you study is really easy for you, really easy to remember. Okay. Coming to liquid solutions, we have gas in liquid, we have liquid in liquid, we have solid in liquid. In gas and liquid, oxygen dissolved in water. We can say soda water is also an example for liquid solutions because carbon dioxide is dissolved in water, right? In soda water, carbon dioxide is a gas used. So we can say that gas in liquid, either oxygen dissolved in water or carbon dioxide dissolved in water. There are plenty of examples available. In liquid, in the case of liquid solution, liquid dissolved in liquid, we have ethanol dissolved in water, that is alcohol, right? Ethanol dissolved in water. Solid in liquid, solid is dissolved in liquid, and we have the example of glucose dissolved in water. Glucose dissolved in water, that's actually sugar solution. Salt solution, you can also write salt solution, salt dissolved in water. Solid solutions, we have gas and solid, liquid and solid, solid and solid and solid. So the solution of hydrogen in palladium, okay, it's an example for gas in solid. Hydrogen is a gas, palladium is a solid. Amalgam of mercury with sodium, that is also an example for liquid in solid. And we have copper dissolved in gold, that is an example for solid in solid. To provide stiffness to the ornaments, we use copper in making of gold ornaments. So make sure you are at least familiar with the examples of solid solutions, because you are very familiar with the examples of liquid solutions, because you are you're actually having a close interaction with liquid solutions in your day-to-day life. So the questions will usually be in the form of solid solutions. They'll ask about solid solutions because you're not much familiar with the solid solutions in your day-to-day life. Also, you can expect questions from gaseous solutions, but still you shouldn't avoid liquid solutions, okay? But at least familiarize yourself with solid solutions, the examples of solid solutions. Okay. Now we are going to see the methods to find the concentration of solution. Okay, there are plenty of methods described in your textbook, NCERT textbook, about the methods of finding concentration of solution. So first of all, you need to know what is concentration. What is the term concentration tells you? Tell me, what is concentration? Is that a concentration you provide to the sessions or to the lectures of your favorite teacher in classroom? Is that the word concentration mean? Yeah, tell me. What is concentration? When it comes to chemistry, concentration means yes, the quantity of solute in a solution. Very simple definition. If you take the case of a solution, any case in a solution, how much solute is there in a solution gives you the concentration of that solution. Let's say the case of, consider two glasses. I have same quantity of water in both. I'm adding at 1 spoon. I'm adding 1 spoon of sugar to this glass 1, and glass 2 has 5 spoons of sugar. 5 spoons of sugar. Let me ask you, does glass 1 have greater concentration or glass 2 has greater concentration? If I say glass 1 has greater concentration, will you agree with me? If I say glass 2 has greater concentration, will you agree with me? Think. Which has greater concentration? I've already defined what is concentration. Concentration means it's actually the quantity of solute present in a solution. And I've already explained this, the case of glass 1 and glass 2. I've same quantity of water, so the solvent amount is same. But in glass 1, I've added 1 spoon of sugar. In glass 2, I have added 5 spoons of sugar. Because, what is sugar in this case? It's a solute. And is the quantity of solute same in the two glasses? No, it's not. Which glass has higher quantity of solute? Glass 2. So definitely the concentration is higher in glass 2. Clear? Wherever the concentration of solute is higher, it's actually the concentration of solution. If the quantity of solute is high, then the concentration of the solution is high. So today, we are actually going to familiarize ourselves with different methods of finding concentration of a solution. Okay, there are actually 7 different methods to find concentration. Which are they? You might have heard these terms in your class 11, and some of you might have done a lot of numerical problems in all such methods of finding concentration, and they are mass percentage, volume percentage, mass by volume percentage, parts per million, mole fraction, molarity, and molality. I'm damn sure that you have studied molarity, molality, and mole fractions in your previous classes. I'm sure. But I don't know whether you know much about the parts per million or the mass by volume percentage, etc. So whatever, doesn't matter. Let us start with the first one, mass percentage. So from the term mass percentage, it's very clear that we are going to find the percentage of something, right? And what the percentage of what? Mass. And the mass of what? Solute. Obviously solute, because we are finding concentration, right? Mass percentage is a method to find the concentration of a solution, and the concentration depends upon what? The quantity of solute, right? So obviously we're going to find a percentage. Percentage of what? Mass. Mass of what? Solute. So what comes in the numerator? Mass of solute divided by total mass of the solution into 100%. We are going to find percentage, right? So we need to multiply it with 100%. Clear? Is it clear? Mass percentage. We are going to find the percentage of the mass of the solute. So mass of solute should come in the numerator section, and denominator we have the total mass of the solution into 100%. If I have a solution combined with two components A and B, if I need to find the mass of A, what should I do? What should I do? I have the mass of A. I don't have the mass of A. Sorry, I need to find the percentage of A. How much percentage of the entire solution is the contribution of A? I make a solution by combining A and B. I need to find the mass percentage of A. What I do? What should I do? What will I do? The mass of A divided by mass of the solution into 100% will give me the mass percentage of A. So if I know the entire mass of a solution, and if I know the mass of a particular component, I can definitely know how much percentage of the solution constitutes this this component. Very easy. For example, 5% of aqueous solution of glucose. 5% of aqueous solution of glucose. What does it mean? What does it tell you? 5% of aqueous solution of glucose. Aqueous solution means the solvent is obviously water. And glucose, 5% of glucose means it's a solvent. It's a solute. 5% means 5 grams. So 5 grams of glucose is dissolved in 95 grams of water, making it to 100 grams of solution. If it's 10% of any aqueous solution of NaCl, it's actually 10 grams. It's actually 10 grams of NaCl in 90 grams of water into 100%, right? Actually, it's constituting 100 grams of solution. Clear? Now we're going to find volume percentage. If you know mass percentage very clearly, it's really easy for you to understand volume percentage, because the term volume percentage means we're going to find the percentage of volume of solute or any component of a solution. We need to know the volume of that component divided by the total volume of the solution into 100% will give me the percentage, the volume percentage of that particular component in that particular solution. Okay? Mass by volume percentage. Mass divided by volume. Mass in the numerator, volume in the denominator. Mass of what? Mass of the solute or mass of the component divided by volume of what? Volume of the solution into 100% gives me mass by volume into 100 percentage, the mass by volume percentage. Okay. Now comes parts per million. Parts per million. You might have heard of ppm in your previous classes, mainly in physics in the first chapter, units and measurements. You might have heard of ppm, parts per million. Parts per million is actually a method of denoting substances in trace quantities, very little, very minute quantities. So how are we going to calculate parts per million? Usually, in the question papers, I have never seen a question from parts per million. They usually ask to calculate the molality, mole fraction, or the mass percentage, or the mass by volume percentage, etc. Parts per million, I haven't seen a question, but I could tell you what parts per million actually mean. Parts per million means, consider there is a solution. There are two or more components of it making the solution, and each component has a lot of parts. So, parts per million means number of parts of a particular component. Number of parts of a particular component, say A, divided by total number of parts of all the components into 100%, 10 raised to 6, into 10 raised to 6. That is parts per million. Okay? If you have a solution that is made up of a lot of high number of components, and each component has a lot of parts, if you need to find the parts per million of a particular component, what you have to do, and mainly if it is present in trace quantities, very minute quantity, what do you have to do? Number of parts of the component divided by total number of components of total number of parts of all components into 10 raised to 6, into 10 raised to 6. The 10 raised to 6, the power you shouldn't forget, 10 raised to 6. Next, mole fraction. What is mole fraction? When I was studying in plus 1, plus 2 classes, I really loved this concept of mole fraction. I don't know why, but it's actually a very, 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 very easy concept. Mole fraction. It's really easy to find the mole fraction of any substance, and I was eagerly waiting for the question asking find the mole fraction of this, that, this, that. I was eagerly waiting for that question. Okay, I really loved that concept, and I really hated molarity and molality. I don't know why. I don't keep that hatred now or such kind of hate. So, coming to mole fraction, this is actually not x. How do you represent mole fraction? The symbol is chi. The symbol is chi. This is wrong. You should somewhat extend the alphabet x that you know. Okay, this is x. If you extend x longitudinally, vertically, you get chi. Chi is a symbol. Chi, that's how we pronounce that symbol. We call that symbol. Okay, so we need to find the mole fraction of a component. Say we have A, B. A is a solvent, B is a solute. I need to find the mole fraction of A. A means solvent. So what you have to do is, you need to know the number of moles of A. If I need to find the chi A means what? Chi A means mole fraction of A. So for that, we need to know the moles of A divided by total number of moles of solution. Total number of moles of solution means Na plus Nb. Clear? If I need to find the mole fraction of a component, we need to find the number of moles of the component divided by total number of moles of the solution. If solution constitutes A and B, which are the two components of the solution, total number of moles of the solution means number of moles of A plus number of moles of B. So if I want to see the mole fraction of B, chi B, what I have to do? Tell me the equation. Nb by Na plus Nb. number of moles of solute divided by number of moles of solute plus solvent. Solute plus solvent. Shall we do a problem now? Calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H6O2 by mass. So we need to find the mole fraction of ethylene glycol. So for that, we need to know the number of moles of ethylene glycol, and also we need to know the number of moles of water, because ethylene glycol is mixed in a solution. Consider it's a solution of it's an aqueous solution of ethylene glycol. We have 20% of ethylene glycol, means 20 gram of ethylene glycol, divided by how do we find the mole fraction? How do we find the mole fraction? We need to know the number of moles of ethylene glycol first, right? So given mass by molar mass. I hope you know that equation. Anyways, I'll tell you. Chi ethylene glycol, right? Chi B equal to NB by Na plus Nb. Nb, number of moles of ethylene glycol, means given mass divided by molar mass. So, what's the given mass? 20% of ethylene glycol means 20 grams divided by 12 into 2 plus 6 plus oxygen 16 into 2. It is 62. So find the answer and substitute. That is for NC6 C2H6O2. Now we need to find the number of moles of water, because it's dissolved in 80 grams of water. How do we find it? 20% of C2H6O2. And we have 100%, right? Total 100 grams of the solution. So 20 grams of C2H6O2, that is ethylene glycol, means 100 gram of the solution minus the grams of solute is grams of solvent, 80 grams. Given mass by, what's the molar mass of water? 18. You'll get NH2O. And finally, what you have to do is C2H6O2 divided by NH2O plus N ethylene glycol. C2H6O2. Okay, this is the format of doing this problem. Now we are coming to molarity and molality. I've already told you that in my class 11 and class 12 days, I really hated this concept of molarity and molality, because it's really confusing. It was really confusing to me, but now it's not. So I have found a method to solve the issue of confusion between molarity and molality. See, molarity and molality is different in the term just by a single alphabet. In molarity, we have R. In molality, we have L. L here, right? In molarity, we have R. In molality, we have L. When we're going according to the alphabetical order, in the ascending order, which comes first and which comes, which is elder and which is younger? Which is younger? Actually, L comes, and after that, R comes, right? In molarity. So consider R as an elder sister. Elder sister. L as a younger sister. So molarity has because it has an R. It has a R in it. It is definitely going to have capital letter M, because it is having R. It is having an elder sister. Okay. And molality, it's having L in it. L means it's younger sister or younger brother or younger sibling. So it is going to have a small letter M. So I'm not going to explain what is molarity and what is molality in deep, because you already know what is molarity and molality. Molarity means capital M, means number of moles of solute by volume of solution in liters. And molality is number of moles of solute by mass of solvent in kilograms. So coming to its equation, moles of solute means NB divided by WB, given mass by molar mass, into volume of solution in liters, volume in liters. Consider the question provided to you. They have given volume in milliliters. What will you do? Instead of liters, you are provided with a volume in milliliters. Convert it to liters. So for that, just multiply the numerator with 1000. Simple. In the case of molality, NB by WB into mass of solvent in kilogram. Mass of solvent means WA in kilograms. In kilograms. If it is given in grams, just multiply the numerator with 1000. Okay? We have a question here. Calculate the molarity of a solution containing 5 gram of NaOH in 450 ml solution. 450 ml solution, we have 5 grams of NaOH. We need to find the molarity. What is the equation for capital M? Number of moles of solute into volume of solution in liters. NB could be found by just dividing the given mass by the molar mass of NaOH, that is 40. So substituting this here, and we have found this part. Volume in liters. The volume is given in milliliters. So just multiply the equation by 1000, and in the denominator we have 450. So let me tell you, the equation will be as such: 5 divided by 440 into 450 into 1000. This is a volume in milliliters converted to liters by multiplying with 1000, and this is the NB by WB, that is number of moles of solute portion. And next one is calculate molality of 2.5 gram of ethanoic acid in 75 grams of benzene. Molality small m means number of moles of solute divided by mass of solvent in kilograms. WA in kilograms. But here it is given in grams. So mass of solvent in grams, and multiply the numerator with 1000. So how do we find NB by WB? That is number of moles of solute. 2.5 grams of ethanoic acid. Okay, 2.5 grams of ethanoic acid, and the molecular formula is given here. Just find the molar mass of ethanoic acid. Substitute it here. For WA, you give 75, and you must multiply it with 1000. That's all. Okay, so for the time being, we are stopping a class here. Hope you all enjoyed today's session, and don't forget to learn all the topics which I've taught you today, and you must watch my next session only by learning the topics which I've taught you today. Deal? Is it a deal? Is it a deal? If it is a deal, yeah. Punch. Okay, so for the next session, before the next session, you must be thorough with the topics which I've taught you today. Clear? If you have any kind of doubts in the topics which I've taught you today, just comment in the comment section. You can comment your doubts, okay? And today we have dealt with the topics of solution, the two components of solution, that is solute and solvent, and aqueous solution, non-aqueous solution, binary solutions, and the different type of solutions differing in states, gaseous, solid, liquid, and the examples for each kind of solute solution. And also, finally, the 7 methods of finding concentration of a solution, that is mass percentage, volume percentage, mass by volume percentage, ppm, mole fraction, molarity, and molality. So you must study the topics which I've taught you today. Okay? Fine. Okay, then we'll meet in another session. So till then, bye.